Hello, this is your host, and you're watching this channel. It was a day like any other on the Yucatán Peninsula 66 million years ago. Birds were tweeting, insects were buzzing, and dinosaurs were probably stomping around somewhere. But that all changed in an instant when a massive asteroid slammed into Earth at about 22 miles per second. Resulting impact triggered a series of events that led to the extinction of the dinosaurs and paved the way for mammals like us to take over the planet. This event, known as the Chicxulub impact, has left its mark on our world in more ways than one. And scientists are still uncovering new insights about what happened all those years ago. So let's talk about the asteroid that killed the dinosaurs, the evidence we have of its impact, and how it forever changed our planet. The first piece of the puzzle is the asteroid itself. Scientists estimate that it was about 6 miles wide and was traveling at a speed of roughly 22 miles per second. When it struck Earth, the impact was so powerful that it left a crater nearly 180 miles wide and 12 miles deep. This crater, now known as the Chicxulub Crater, is located beneath the Yucatán Peninsula in Mexico and provides a wealth of information about the impact itself. To understand the true scale of this disaster, let's compare it to something we're more familiar with. Like the atomic bomb dropped on Hiroshima during World War II, while both events involved massive explosions, the asteroid impact dwarfed the atomic bomb in terms of energy released. The asteroid impact unleashed approximately 100 trillion joules of energy, whereas the atomic bomb released about 2 million joules. That's a staggering difference of 50,000 times. It's like comparing the Big Bang to a sparkler. But what makes the asteroid impact such a significant event in Earth's history is not just the explosion itself, but also its far-reaching consequences. In the immediate aftermath of the impact, the force of the collision generated enormous heat, estimated to be around 3,000 degrees Fahrenheit. This intense heat ignited massive wildfires across the globe, which released even more dust and debris into the atmosphere. The impact also triggered a series of devastating tsunamis that raced across the planet, inundating coastal regions and causing widespread destruction. These tsunamis were some of the largest ever recorded in Earth's history, with waves reaching heights of up to 300 feet. As the dust and debris from the impact settled, it blocked out the sun, plunging the planet into darkness. This sudden lack of sunlight caused temperatures to plummet, leading to a global winter that lasted for years. But the effects didn't stop there. The impact also released massive amounts of sulfur dioxide into the atmosphere, which formed sulfuric acid clouds. These clouds reflected sunlight back into space, further cooling the planet and disrupting weather patterns. The combination of falling asteroids, wildfires, tsunamis, earthquakes, and a global winter led to a mass extinction event from which only a small fraction of species survived. Among the most iconic victims of this extinction were the dinosaurs, whose reign on Earth came to an abrupt end. But not all species were wiped out. Mammals, birds, and some reptiles survived, setting the stage for the rise of new species, and eventually, the rise of humans. The Chicxulub Crater is rich with evidence of this cataclysmic event. It contains shocked quartz, which forms when rocks are subjected to immense pressure and temperature changes, as well as tektite, which are formed from molten rock that was blown into the air during the impact. The crater also contains a layer of iridium, an element that is rare on Earth, but abundant in space. This layer of iridium is the same age as the KT boundary, a thin layer of rock that marks the end of the Cretaceous period and the beginning of the Paleogene period. The iridium layer can be found all over the world and is thought to have come from the asteroid itself. In addition to these physical pieces of evidence, the Chicxulub Crater also holds clues about the impact's timing. By studying the age of the crater itself, scientists have been able to determine when the impact occurred. They've concluded that it took place at the end of the Cretaceous period, around 66 million years ago. This precise dating is important because it helps scientists understand the sequence of events that unfolded after the impact. But what if there was more to the story? What if there was another asteroid involved? Some researchers have proposed that 2 asteroids may have collided with Earth around the same time. One would have been small, about 5 miles wide, while the other would have been much larger, around 60 miles wide. If this scenario is true, it could explain some of the more puzzling aspects of the impact, such as the presence of shocked quartz and tektite. The smaller asteroid would have contributed to the wildfires and tsunamis, while the larger asteroid would have caused the mass extinction event. However, this hypothesis is still being debated. Not all scientists agree that two asteroids were responsible for the end of the dinosaurs. It's possible that all the evidence can be explained by a single impact. But the idea of two asteroids remains an intriguing possibility. In recent years, scientists have turned to computer modeling to better understand the Chicxulub impact. By simulating the impact, they've been able to test different hypotheses and get a better sense of what may have happened all those years ago. One team of researchers developed a computer model that simulated the formation of the Chicxulub Crater. Their model showed that the asteroid impact would have created a crater about 170 miles wide and 8 miles deep, which is remarkably close to the actual size of the crater. Another team of researchers developed a model that simulated the climate effects of the impact. Their model showed that the impact would have caused a rapid onset of winter, followed by a gradual recovery over several decades. This model supported the hypothesis that the impact had a profound and long-lasting effect on Earth's climate. The study of the asteroid that killed the dinosaurs is not just a fascinating journey into the past. It's also an important reminder of the delicate balance that exists in our world. The impact of Chicxulub was a catastrophic event that forever changed our planet. It serves as a reminder of the power of nature and the importance of understanding the forces that shape our world. As we continue to explore and learn more about the asteroid that killed the dinosaurs, we also learn more about ourselves and our place in the universe. We learn about the resilience of life in the face of adversity and the incredible adaptations that allow some species to thrive in the most challenging environments. We also learn about the fragility of our planet and the importance of protecting it from future impacts. The asteroid impact that killed the dinosaurs is a testament to the power of scientific inquiry. As we continue to explore and learn more about this event, we also learn more about ourselves and our place in the universe. So let us continue to explore and learn, to question and discover, and to protect and preserve the amazing planet we call home. And thank you for watching. If you enjoyed this video, please subscribe and leave a comment below with any suggestions you have for topics that we should cover in the future.